Hi everyone. This is a session about a local AI setup on, I'll keep it reasonably short. I've made a slightly longer one. This one is just a glimpse of what's possible with two 12GB 3060 NVIDIA GPUs. You can see here are the NVTop stats, like here's two GPUs, how much RAM is used. Here you see the power. I've kept it to 150 watts. In idle, it takes around, as you can see, 11 to 80 watts per graphic cards. There's so many details about this, but this is just, enjoy the show. I'm gonna do some showcase here with local LLMs on reasonably affordable hardware. So that's a 5-year-old gaming mainboard, MSI Mortar Max B450M with 64GB of system RAM, DDR4, and yeah, 2 GPUs. I set it up. It's a wild and rough setup so far. I'm not using this machine for production yet. It can see images, it can watch videos, and it can write code, read and write code. Let's start with, here's the web interface by Llama, and here's the web interface, same backend, OpenWebUI. OpenWebUI has more features of things you can provide on the contacts and sessions and logins and so on. This is a small fire and forget UI that comes with Llama Server. I've loaded the 35 billion parameter, 22GB file on this machine. You can see here the graphic card one has 10 point something gigabyte of 12 loaded. Here almost 12 GB loaded on the second card. Are you there? It is. So, new chat. Let's give it something. Here's, I work a lot with digital preservation and key value metadata. Look at this. That's a plaquette, like a thing where a machinery has information about on it. Looks like this. A little bit worn. What's on the image? I was looking at the image. You can see on the left-hand side here, GPU 1 goes up. GPU 2 does not a lot of computing so far. So you can see here, one GPU is doing 97% of the work. The other one's idling. Every now and then, it has a few spikes. GPU is doing something. CPU is not doing a lot. You can see down here, it's doing other stuff basically. So it's not busy on the CPU. It's busy on the GPU. Power consumption is 50 to, let's say, 80 watts. It's not even peaking on the 150 watts I've capped it to. It says, yeah, it's a metal nameplate of an industrial compressor. Totally true. Agre, yes. Garsten St. Ulrich, Wien, Austria, true. Name value, name value, name value, hardly visible, so it's guessing a lot because it's really hard to read on this. But it's doing a good job. Now say, output the key value information as JSON. Any follow-up questions on images process quite fast because it doesn't have to look at the image again if the session is still open. Everything you see here does not only work on a web interface, but you can also do it on the command line, which is awesome because anything you can do it on the command line, you can easily reproduce and automate. So I can do this on a bunch of images on any storage that this machine has access to. There we go, manufacturer. So you've got key value, nested key value. Of course, you can fine tune this. You can give it some specification about what JSON you want to have. But I said it's going to be a quick flyover. Completely different image. It's from an outdoor event. Summarize what's on the photo. I'm looking at a photo again. Here you can see, whoop, GPU goes up. This setup is not yet optimized. It's slightly tuned. Thank you, Martin. Thank you, Thomas. And yeah, again, everyone else who's made it possible that these things are available, not just for free, but actually as free and open source software. This is very powerful stuff. And it should be in good hands. It's done. Outdoor community or family event, sunny day, likely park or schoolyard. Absolutely. Setting, grassy fields, everything that's written here is true. A joyful, well-attended outdoor gathering focused on children's activities, families, community members. True. What's in the background? Follow-up question again. Clear blue sky. Is there a mountain? Interesting. Because there actually is not. Huh. So I was checking if it mistook this for a snowy mountain, but it figured out it's not. It's a tent. Wow. Next one. This time I'm gonna feed it a video. I've made a very small sample of 5 seconds of a music video. Summarize the plot of this video. Of course, it takes slightly longer. It's not gonna watch the full video. So I have not yet checked the backend how it's actually doing this. So this is Llama server that's receiving over the web UI a file. So I'm uploading it on my local client. It's putting this on the server back there. It's a sample that has 810 kilobytes. I just use it for testing. It's 5 seconds at 24 frames per second approximately. But it's not looking at all the images. It's only taking, I think, around 10 images from those 5 seconds. So it doesn't do all the full frames. Probably it can be told to do this, but by default it doesn't. I'm really assuming it's using FFmpeg in the background because it does decode the video. It can really, well, you'll see. There you go. What do we see? A sequence of events related to computer hack. Here's a summary. Unauthorized gaining access computer system. You see a login screen, credentials, fingers typing rapidly, close-up shots. Logged in, file deleted, block formatted, format complete. Let's see if this is true. It is. It's exactly what's on the video. So those were quick 5 seconds. There you go again. Login screen, file deleted, block formatted, format complete. List me all text found in video. There you go. This is true. Wow. Something else. Here, what's standing out on this image and why? It's a chessboard with 2 Lego blocks. I assume the Lego blocks are there because figures got missing, because this is what happened to our chessboards all the time over years. decades actually. Not centuries, just decades, but you know, figures get lost or kids chew on them or whatever. So there you've got 2 Lego blocks. Let's see if it figures out that they are there. While it's calculating, on the left-hand side, we're still at around 50 watts each, 50, 60 watts each. We get an answer. So this is the performance. You see here, around 55 tokens. This is the speed I get with this setup. Maybe it could be tuned to go faster. This is an A3B MTP Qwen3 model that I'm very happy with so far. Thank you for everyone putting this together and making it available, because the false positives are extremely low in my work and tests so far. It's not just a chessboard, it's a canvas for a reinvention, huh? Yeah, the Lego blocks stand out because they're unexpected, colorful, and symbolize creativity breaking into tradition, turning a serious game into something playful and imaginative. I will show you the command line I've used to start this Llama instance, because I think that's the reason it comes up with such a creative interpretation, instead of just saying, well, probably blocks were missing. Says like mixing classical music with pop art. So here's the Llama command line. Llama server and so on, load this model, mmproj. Why can I not zoom in? Here we go. Temperature 0.6. It feels creative today. I've got one more for you. New conversation. This time, what's on the image? By the way, while it's loading, I've put something very useful together. This is a monitoring screen. Here you go. It's showing the same NV top and B top on a touch screen, which is attached to lots of cables here. A Raspberry Pi 4, which runs Lineage OS. So I basically have a stationary smartphone operating system. I have an Android running here on a Raspberry that serves not only as stats, but also for anything that uses apps, and I don't want to put them on my phone. But that's going to be another video for another time. Train sleeper compartment. True, absolutely true. That photo was taken on a train. There you go. Here, you've got the door, train sleeper compartment. It figured out what the book was that's on here. Snow Crash by this and that, and tells me stuff about this, and this is perfect reading material for a late night train ride. Well, it's sci-fi dystopian. I prefer utopian stories these days, but it's an interesting book. So now, what's this book about? Summarize in 300 words. Let's see. Everything you see here now is gathering information only from what it has inside its model. I have not given it any additional information. I have not given it access to the internet. Snow Crash and so on. There's YT. I've read the book. So yes, that's what the book is about. Well, if it's about books, do you know the book Momo? While we're at it, let's check if it knows about some good literature. It does. What about Never Ending Story? So you can see that talking to it is, I find it reasonably fast, usefully fast. So if I use this as an assistant or for coding, or even if I imagine running this in the background on data, like, so here's archival long-term preservation data or personal data or whatever. This is not going outside. This is not doing anything on the internet. This is just running on local hardware in your local network on hardware like this. So if that's possible with two 350, 400 euros cards, imagine what you can do with bigger hardware. I'm asking and telling this to people who work in institutions who are considering using AI for their work. I'd rather suggest getting into having your own stuff on premises than outsourcing all of this. And this also allows to learn what actually happens, not just using this and something happens, but getting control over this. So we've got the never-ending story. I know his name was Bastian. There's a trio. Fantasia. Sounds reasonable. And what is the name of... What's the name of the... What was it? A princess in Never-Ending Story? There. 60 watts, 90 watts. So it's doing like this, but you don't need a nuclear power plant to run this. Montenkind. Yep. So that was it. Whew. Welcome to the 21st century. Let's make it a good one. Let's take control over these machines in a good way. See ya.